All right, so lecture 7, incrementing and type conversion. So a literal value are numbers that you literally type into the program. So int I equals 34. That's a literal value. I literally typed it, whatever its value is, into the program, right? Long x equals 1,000,000. I literally typed in the value into the program. Double D equals 5.0. I literally typed in the value into the program. Same with this. If I did string name equals John, I literally typed it into the program, right? Versus this right here, input.next, right? Prior to me running this program, I don't know what name is going to be. I didn't literally type it into the program. It could be anything. I mean, you could type whatever you want or enter in whatever name you want into the console. I don't know. Same with this. Double, let me change the color of this. Let's see, what color looks good on this? Here we go. Same this, double perimeter equals 2 times radius times math.pi, right? I don't know what perimeter is going to equal prior to me running this program, right? And prior to me knowing what radius is. Now radius, when we did it the first time, radius equaled 5.5, right? That was literally typed into the program. However, the second time we read it from the console. So again, we don't know what radius would have been prior to us running the program. All right. That's what a literal value is in Java. Same goes for strings. You can have a literal string as well. All right, so now we're going to talk about arithmetic expressions. So all of you are math whizzes, so you know arithmetic expressions. So of course we do our parentheses first, right? Parentheses first. I'm sorry. It'll be, since these parentheses are inside of those, right? We're going to do that one first, numero uno. Right? Once we do that, we're going to jump out of those parentheses. We're going to do this one first, or 2. Then we're going to do these parentheses, number 3. Then we're going to do this divide over here, and this divide over here, this multiplication over here, right? And then lastly, 7 and 8, right? And that's how you separate equations into Java. So you see this complex equation up here. The way I think about it, if you're trying to type an equation into a scientific calculator, you can't type it in like this, like you see right here. You have to separate it out and use parentheses to show your order of operations. The same rules apply for Java. You have to separate it out on one line or 2 lines, it doesn't matter. But you must have your parentheses to tell the program the order of operation you want to follow, okay? So I want you all to try to convert this on your own. I'll give you about 5 to 10 minutes to do that. All right, let's continue. All right, this is the equation. All right, this is the equation, right? This is what I got out of that. So the first thing we want to do is look at this top part right here, 1 minus 2x. So we want to put that inside of parentheses because we want that to be done first, right? Or at least part of that program right there. If we take it incrementally, we want 1 divided by 2 times x to be done, and then we want to divide all of that by 3. So I put all of that inside parentheses as well. So if you look here, 1 minus 2 times x divided by 3. All right, I move on to the next one. So again, this whole top part I put inside of parentheses. 4 times parentheses 3 times y plus 1, close parentheses, open parentheses, 6 plus 9 times x, close parentheses. And then I close the whole top part off. So if you look here, I do open parentheses, close parentheses for the top, 4 times open parentheses, 3 times y plus 1, close that, times this, and then that's the whole top part, right? And then I want to divide it by 2x, so 2 times x for the bottom, and I add all of that within a parenthesis as well. So this whole portion right here is within a parenthesis, so right here. Add that to this whole third part of the program, 3 times open parenthesis, all of that good stuff right there. So that's what I did right here. 3 times open parenthesis, 2 times x, or 2x, divided by x plus 1, plus x plus 1 divided by 4x, or 4 times x. And I put all of this within parentheses. So you see that here. Any questions? Any questions at all? All right.
So if I like miss a step, like when I was writing that equation, the Java would throw me back like an error or something, or it would just execute the code like how it was supposed to be, how I made the error.
You said you made an error?
Yeah.
With this right here?
No, I'm saying like if I did though, I was just like hypothetically.
Yeah, so it depends. If you're missing like a closing bracket, it will tell you there's an error, right? But if you're not missing a closing bracket, and say for example, I just removed one here, so let's see. If I mistakenly put the closing bracket right here, it's not going to tell me there's an error, but my final output will be wrong.
All right.
You know, so that's one of the issues or difficulties with programming as well. There's no error technically. The code works perfectly, right? It compiles and it runs. However, your final output will be wrong. And so that's when you're starting to something called debugging, and you're trying to figure out where in your code it's going wrong, where in my equation is it going wrong. And to make it a little bit easier, you could separate this out and say double number equals just that part, and then you could do the inner and do double number equals number minus this part right here. You know, you could just separate it all out, and you can see at which step that the numbers are calculated incorrectly. But yeah, it will run, but it'll give you the wrong number. All right.
Okay.
All right, so let's continue. So evaluating expressions. So again, I kind of talked about this before. The first thing we're going to do here is what's in the parentheses, right? That's step 1. And then we do our multiplication, right? Then we do our multiplication again. Now we just move down to addition, addition, and finally our subtraction, right? And that's our final output. All right? All right, so now we have a couple shortcuts in Java that make it a lot easier for you to do some coding. So we have a plus equal, minus equal, times equal, divided by equal, and modulo equal, right? And so pretty much all those are is if I do I plus equal 5, right? All I'm saying is do I or set I equal to whatever is currently I's value plus 5. Same thing with subtraction, whatever I's value minus 7. Multiplication, whatever I's value times 7.8. Division, whatever I's value divided by 65. And then modulo, whatever I's value modulo 4.3. Remember, 4.3 gives you the remainder, okay? So let's do a coding example of this, and I can show you, or before I do that, is the next slide, yes. And then you also have incrementing and decrementing. So incrementing allows you to increase your number by 1, or vice versa for decrementing. And what you'll see here is you have pre-increment and post-increment. What happens is it'll increment the assignment or the variable either before you do this equation or expression or after. By that I mean, if you look at this example, int I equals 10, right? And let's say int new num equals 10 times I plus plus. So that is, that is a post increment. So it's going to occur after you do your expression. So int I equals 10, int new num equals 10 times I, and then we do I equals I plus 1. Incrementing increments it by 1, okay? However, if you do a pre-increment, there you go, the final value of I will equal 11. However, in int num, we're multiplying 10 times 10. So new num would equal 10. However, if we do a pre-increment, right, if we do 10 times plus plus I, that plus plus I will occur before that expression. All right, so in reality, we're doing int num equals 10 times 11. So you see here, new num would equal 110, I equals 11, okay? And let's do, I'm going to do an example with you all real quick in NetBeans. So let's go on down here. Let's create int I equals 10. Let's do system.out I. Let's just print out I. All I did was comment out all of that. So let's hit run. That shouldn't have been what it came out with. Run file. Let's see. What is it running? Something here. Let's see. Hold on, it is not liking this statement right here. Negative 710. Where is it getting that from? I don't get it. Let's see, hold on a second. All right, so int I equals 100, system.out.println I. if I do I plus equal 17, you'll see, and then I print out I again, you'll see I should equal 117. See? Plus equal. If I do I minus equal 10, I will come back down to 107. However, if I do I plus plus, I plus plus and I minus minus, and plus plus I minus minus I, they only increment or decrement by 1 each time. They don't go any higher than 1. You can't change that. All right. Then I plus plus, I minus minus should take it back down to 107. All right. You clear on what plus equals 17, minus equal 10, plus plus I minus minus does? All right. Well, and then the post and pre-increment, so let's do another number. So int number equals 200, right? Now let's do number plus equal I plus plus, right? Let's system dot out dot print line number and system dot out dot print line I. I'm going to delete all of this up here. So right now, I should equal 100. Number should equal 200. And then let's do an equation. So number plus equal I plus plus. And then system dot out dot print line number and I. All right. So at the end of this, number should equal 300 and I will equal 101, right? Although I'm incrementing I right here, I'm doing it after this assignment. So right here, 100, 200, 300, 101. However, if I swap this plus plus, it's going to do it before this assignment. So instead of I equal 101 after, I is going to equal 101 before I do the addition, so 301. Honestly, in all these years of programming, I've never used I plus plus, plus plus I in an assignment statement. If I need to, I'll do this right here, I plus plus, and then I'll do plus equal I, right? I usually do that, or I'll do plus equal I, and I'll do I plus plus down here. One, it makes readability easier for somebody who's coming on after you to see what you're doing. And two, for me personally, it makes it easier for me to read it too. So those statements would do the same thing if I do this up here as well. All right, same thing. I just do them, I separate out the statements. I don't do it all in the same statement down here. All right. All right. So we have several different shortcuts in Java, right? Operators, examples, equivalent. So plus equal, here's an example of that, is equivalent to I equals I plus 1. And I'll show you that. So let's do int I equals 100, right? And then let's do system.out dot print line I. Okay. If I run this, you see I equals 100. Well, if I do I equals I plus 10, If I print out I again, I should equal 110. Look, I can also do plus equal 10, which is the same thing as what I just put. It's just a shortcut. Same thing with minus equal. So if I do minus equal 10, it'll subtract 10 from I. If I do multiplication equal, it'll multiply by 10, division equal, divide by 10, or modulo equal. You do the modulo, which is the remainder, which is 0, right? 10 goes into 100 perfectly 10 times. The remainder is 0. Okay? And again, this is the same as doing I times 10. Right? Or times equal. Same thing. They're just shortcuts. You can write it all out if it makes it simpler and easier to understand for you. These are just shortcuts to use. There's also something called increment and decrement. So let's do plus equal 1. Right? I equals 101 now. Well, instead of doing all of this, I can just do I plus plus and call it a day. Again, it's another shortcut. And it comes in handy when you just want to increment a number by 1. Say, for example, I'm playing soccer, right? And I have int my score equals 0, right? System.out dot print line, start the game. Let's do this first. Oh, let's do that. And then let's do a system.out dot print line, my team scored. All right. So in soccer, you only get 1 point. So my score plus plus, and then system.out dot print line, my team's current score is plus my score. There you go. So my score should be 1 after we scored a goal. You see that right there? It's 1.
So what makes it know that like my score is just +1? Like plus plus is 1.
Plus plus is always 1. Plus plus and minus 1, minus minus, only increments or decrements by 1. If I want to do more than 1, I would have to do plus equal 2. Say, for example, we're playing basketball. Plus equal 2. It's going to increment by 2. When I use plus plus, that's always 1.
Okay, so that can only be 1.
Yes, plus plus can only be 1, and minus minus is only 1. All right. So if I do this again, if I write this out again, the same statement, our new score should be 1 and then 2. Right? So start the game, my team scored, my team's current score is 1. My team score, my team's current score is 2. So plus plus always increments by 1. Okay? All right? And that's what this is, these increment and decrements. So again, you have pre-increment and post-increment, and it just either increments before the statement or after. So if we look here, 10 times, and it's on the right side of the equation. So if you have I plus plus on the right side of the equation, it's going to increment it after. If you have plus plus I, it's going to do it before. Same thing goes for minus minus. So if we look here, I equals 10, int new num equals 10 times I plus plus. Well, in reality, what we're saying here is this over here. I equals 10, int new num equals 10 times I, and then afterwards, I plus 1. So new num will equal 100 and I will equal 11. On the flip side, if we have plus plus I, which means it's going to occur before the statement, you would have int I equals 10, I equals I plus 1, and then 10 times I. So new num would equal 110 because I equals 11 and I equals 11. All right. Now, to be honest with you, I'm never going to ask you to do anything like this, plus plus I and I plus plus. In all my years of programming, I've only used I plus plus in situations like I showed you, in these type of situations. I've never had to use I plus plus or plus plus I within an equation. So I never had to do, double max score equals I plus plus times 45 or something like that. I've never had to do something like this. One, it's just confusing to do for either yourself or a programmer who's coming on afterwards. So I would just do, if I had to do that equation, I would do I plus plus, and then my semicolon, and then I would do double my score or max score equals I times 45. I would just separate the statements out to make it simpler for myself. Right? It just makes it simpler to understand. I wouldn't put it, I wouldn't do this. I just makes it more difficult to read. Now that is shorter. You see that's one line less, but it's a little bit harder to read from a human readability standpoint. This is just some examples. I think we did this last time, if I'm not mistaken. We went through these. So it should be recorded already, and I'll put that in the video. All right, type conversions. We already did this to a certain degree in our examples. I think it was, problem 1. When we did radius equals double dot parse double, what we're doing is converting input.next, which is a string, into a double. Right? We're converting the type of variable it is into a double. So it's a type conversion. Whereas you can convert integers into doubles, you can convert doubles into integers, vice versa. You can convert the types of variables into many different other types as long as they are compatible. For example, you cannot convert a string into a radius into a double without double.parse double. You can't just say radius equals this string. It won't work. It'll give you an error. But when we look at this, there are 4 main rules when it comes to numerical conversions, okay? Doubles, if there's a double in the equation, whatever else is going to be converted to a double. And then the next step down will be a float. The next step down will be a long, and the last step will be an integer. So we look here, if one of the operands is double, the other is converted into a double. So you have a double F, int J. J will be converted into a double for this expression, and the result will be a double. If we continue, floats, int J, J will be converted into a float for this equation. For longs, again, that int J will be converted into a long for this expression. And then lastly, we have, if both of them are integers, it'll stay at int, okay? Then we have something called type casting, which is when you're trying to cast one variable into another, right? And all you do is you put the variable you want it to become into parentheses, okay? So if we look here, we look at this example. If we do double F equals 65.54556.9, right? But we want to convert F into an integer, so int F converted equals, I can cast it with int F. right? I want to convert f into an integer. So let's do system.out.println f, and then system.out.println f converted. And what you'll notice is when you convert a double to an integer, again, integers are nothing but whole numbers. So when you convert it, all the numbers after the decimal will be dropped. There is no rounding up, there is no anything else, it's dropped. So technically it's rounded down, regardless of what the number is. So this could be 65.9, and it will still be converted down to 65. Everything is dropped, okay? So f converted becomes that. F converted plus f plus. So you see that f is 65.945589, f converted is 65. And vice versa. So if I want to, if I have int f equals 65, then I have double f converted equals double. I don't even have to put double because remember, anything that's an int will be converted into a double regardless, but I can explicitly tell it what I want it to be converted to. You see 65.0 is now a double. If there's a decimal point, it's a double or a float. If it doesn't have a decimal, it's an int or a long, okay? Then 9 gets dropped in this equation. So with this statement, right, we have int I equals 1.5 divided by 40. 1.5 divided by 40 is not an integer, right? It's not. So what we need to do is add in that type conversion into an integer, okay? We don't necessarily have to put that because in this equation, whatever is on the left side, it will convert this over here. But for clarity, we can because we know this is not going to be an integer, but we want an integer on the final result. So we explicitly cast it. We tell the program exactly what we want it to convert to. And then we have strings and numbers. Again, in this class, we're only focused on doubles and integers. So our main methods will be double.parseDouble and integer.parseInt. Right? That's what we'll be using for the majority of this class. So if I go back to our radius equation, so system.out.println, please enter 2 radiuses or radii. I'm going to say radiuses, but I think it's radii. All right. Let me just go with radii. Let's just say 2 numbers. Please enter 2 numbers. There we go. All right, I need a scanner. Scan equals, or scanner input equals new scanner, system.in. Right. Let's do a double first num equals input double dot parse double input dot next, and then int second num equals integer dot parse int input dot next, system dot out dot println first number plus first num, and system dot out dot println second number plus second num. All right. So what this program is doing is going to say, please enter 2 numbers. I'm going to type in 2 numbers. It's going to read those in, convert it to a double, and convert it to an integer respectively, and then print those back out. So let's run this. Please enter two numbers, 54.78 and 15. And it spits those numbers back out. Let's do print up here. However, remember, with anything, if you're parsing that string, it has to be a number. If you enter in a word, so if I enter in some words, I will get an error. So be mindful of that. We will do some error, accounting for errors later on in error processing. But for right now, know that if this is not a number that you're entering in, it will spit off an error.
So what would happen if I entered in a double for the second number?
It will be converted into an integer. So if I do this, and vice versa, if I put a 54, which is an integer, and then a 556.22235, whatever, actually it will spit out an error. So it will spit an error because that is not an integer. It's trying to convert it to an integer, right? So in this case, you would have to do this right here. You would have to do explicitly cast it, int, right? And then do double dot parse double. Now I should be able to enter 54 and 225.2233, whatever number I want, and it will cast it to an integer. All right.